Hi everyone, welcome to our technical session on supercharging your Android media experiences. I'm Bassam, a product manager for Android Camera and Media. Joining me today are Nevin from Developer Relations and Kailiang from our engineering team. We're thrilled to show you how Android is evolving to help you build more engaging experiences for our users. Let's get started. Our relationship with media has fundamentally changed. It's no longer something we just consume, it's how we create, how we connect, and how we live. More and more, we see how media is a vital element of Android. And as that relationship evolves, we also see that our users are deeply engaged with their media as they use their devices to watch, listen, create, share, and connect. This is why we want your media to feel effortless. Every video you watch, every song you hear, and every story you love should be delivered with brilliant, uninterrupted quality. With that comes a promise to also be your creative partner, making it simple to capture your life as you remember it and craft the stories only you can tell. We strive to deliver media that you don't just see, but you can step inside. To deliver on that vision, we are focusing our investments across key high-impact areas. First, we are continuing investments heavily into quality, power, and performance, ensuring ExoPlayer helps you deliver the most power-efficient media experience on Android that is consistent, reliable, and lag-free. We're also focusing on end-to-end creator journeys, enabling applications to take advantage of our leading-edge intelligent camera with our seamless CameraX toolkit and Media3 editing libraries that unlock magical experiences for our most creative users. Finally, we are investing in immersive experiences our users can feel. As content breaks free from the flat screen, we are building the definitive platform for spatial media. Using our open-source Eclipse engine, we will enable you to capture and playback spatial content on your Android devices. As we build on our core investments, we are proud of the innovative features we have brought to the ecosystem. Working really closely with partners like Meta, we've been able to bring experiences like low-light boost to the hands of many users. We're also bringing more innovative AI features like Magic Eraser and Studio Sound to the platform to enable the most creative users to have the tools to express themselves freely. Besides all the experiences we are enabling, we're incredibly proud to see continued adoption of our Jetpack libraries. We'll share more on how these libraries can help you take advantage of the latest camera and media features on Android throughout this talk. To dive into the details, I'll pass it off to Kailiang and Nevin.
Thanks, Bassam. When we talk about being able to capture in any scenario, we mean giving your users the power to grab the perfect shot every time without friction. We're committed to bridging the gap between system capabilities and in-app features with CameraX. CameraX abstracts away the complexities of the underlying camera hardware, providing a consistent and powerful API surface. Let's look at what's new. For example, starting with version 1.5 of CameraX, you can capture uncompressed, unprocessed DNG images for maximum creative flexibility for pro-level editing. On the video front, we've introduced a widely anticipated feature, high frame rate capture. You can capture fast-moving action at high frame rates and encode it as is for exceptionally smooth video, or directly encode it at a lower frame rate for
dramatic slow-motion video.
For code samples and details on device compatibility and limitations, check out our blog post for this feature. Modern camera experiences will often combine multiple features. But how do you know if a device supports HDR video and 60 frames per second and preview stabilization all at the same time? The new Feature Group API in CameraX removes the guesswork. The Feature Group API currently supports HLG10 HDR video, 60 frames per second, preview stabilization, and Ultra HDR image. You can provide a prioritized list of features, and CameraX will determine the best combination supported by the device, enabling them in order of your list. You might consider using this API to create a settings UI that disables toggles for unsupported options. For more guidance, visit our feature group blog post. Moving on, next, let's take a look at Low Light Boost, a powerful feature for brightening the camera stream in real time for previews and recordings. Instagram recently added support for Low Light Boost to help users capture memories at night with as much authentic detail as possible. With CameraX, implementing the hardware-accelerated AE mode of Low Light Boost in your capture flow takes just a single line, calling the camera control.enable Low Light Boost async API. Check out our developer documentation for guidance on how to enable the software implementation of Low Light Boost as a fallback solution on devices where Low Light Boost AE mode isn't available. So far, we've covered how CameraX can adapt your capture experiences to different environments, from fast action to low light. But users also have a variety of devices now, including foldables, tablets, headsets, and glasses. So it's more important than ever to build a camera experience that can seamlessly adapt to new form factors. Here's Kailiang to show you how.
CameraX already includes the tools you need to build adaptive capture experiences that enable users to make the most of their devices. Make sure to use the CameraX Viewfinder composable to automatically manage reconfigurations, aspect ratios, and scaling to prevent stretches or stuttering previews. This works out of the box, saving you from writing device-specific workarounds. Here, I have some sample CameraX code for setting up a preview use case, and it's important that we store the surface request from CameraX as a state in our view model. We can then pass the surface request into CameraX Viewfinder, and it will handle lifecycle management, recomposition as needed. While we're on the topic of helping users make the most of their devices, here's something cool. We can use the Jetpack Picture-in-Picture library to give users the ability to multitask while recording with CameraX. Going back to our CameraX Viewfinder example, we'll add an instance of basic picture-in-picture from the Jetpack Picture-in-Picture library. We'll also create a function that updates the picture-in-picture params based on where our camera preview is positioned on the screen. And finally, in our CameraX Viewfinder, we will call update source rect hint when it gets positioned. Now, whenever we want to enable this, we simply call enter picture-in-picture mode on this activity.
For example, this might be useful for reading a script while recording.
And finally, looking ahead, CameraX is at the forefront of new format support with the addition of motion photo. Later this year, you'll be able to use CameraX to implement motion photo capture capabilities in your app, which are already supported for editing and playback in Jetpack Media3.
Speaking of editing, next we'll show how the Transformer APIs in Jetpack Media3 are designed to make creative and complex editing easy. A major focus for Transformer has been to enable more complex editing workflows, and the APIs now have support for multi-asset editing. Multi-asset editing refers to the suite of tools necessary to composite multiple input media items into a single output video. This could include, for example, concatenating items one after the other, overlaying them or arranging them for simultaneous playback, and applying operations that span multiple items. In Media 3, you can apply effects and transformations to media with the Effects API, preview the fully composited compositions with Composition Player, and finally export the creation to an output video with Transformer. To apply effects to a single media item, you can create an edited media item, which groups a media item with a list of video effects and audio processors to apply to it. You can arrange multiple edited media item instances into an edited media item sequence, and layer multiple edited media item sequences together into a composition. There are some editing options, like HDR behavior, that you can apply at the composition level. You can then play this composition with a composition player to preview your edits, or pass the composition into an instance of Transformer to export a video with the edits baked in. On top of this, Transformer is packed with new features and improvements, including faster trimming with edit list metadata, so you can quickly create high-quality, shortened video clips by marking the start and stop boundaries using metadata instead of re-encoding the clip. New input format support, such as Android Professional Video for professional-grade editing control. Media3 Muxer as the default rather than the platform Muxer for more consistent behavior across devices. And a more intuitive API for speed adjustment and frame rate setting as part of the edited media item builder. One developer taking advantage of Transformer is Adobe. For their upcoming Adobe Premiere app, Adobe used Transformer as the foundation of their media editing infrastructure to reduce their maintenance costs and ensure greater compatibility across the Android ecosystem, while maintaining the flexibility they need to use their own custom graphics pipeline. Beyond Transformer, to help tackle video encoder fragmentation across the diverse Android ecosystem, we're also introducing the new CodecDB module in Media3. This project leverages extensive testing from real devices to provide data-driven, chipset-specific recommendations for optimal video encoder settings. You can use CodecDB's recommendations to achieve better and more consistent video quality across devices at a target bitrate, all while avoiding device-specific issues. Here's an example where we've encoded a video with default settings on the left and with CodecDB's provided settings on the right. See if you can notice the improvement that CodecDB's recommendations have had. We can look at a single frame for side-by-side comparison. Notice the reduced blurriness in the branches of the bush, the sharper lines in the building, and the clearer delineation between the mountain and the sky. With CodecDB, the API is designed for you to express an intent rather than a granular configuration. In this example, we're optimizing for high-quality recording, but could instead request settings for use cases like live streaming or social media posting. We can also outline any constraints we're aware of, for example, the video resolution, specific codecs to consider, and a target quality level. And if by chance CodecDB doesn't have the data needed to provide a recommendation, we can also define a fallback configuration. At time of recording, the API is still actively in development, so please refer to the latest documentation for up-to-date guidance.
Looking ahead, we're also developing advanced on-device AI-powered effects to help redefine mobile storytelling for users and empower developers to ship premium AI-driven experience across the Android ecosystem. The first of these features that we're excited to introduce is image and video enhance. This model includes tone mapping, denoising, deblurring, and super resolution capabilities. This can be valuable, for example, by enabling to deliver smaller or low-quality media to save on storage and bandwidth costs, and still restore image and video to high quality at the time of delivery. We've been partnering with Instagram Edits app to test this feature, and we'll be rolling it out soon. To give users more creative control, we're also eager to bring Magic Eraser capability to apps through these effects. Magic Eraser leverages on-device models to intelligently remove unwanted objects or distractions from the picture and fill in backgrounds. And finally, to enable clearer and more professional audio in videos, we're launching Studio Sound. This is an AI-empowered feature designed to improve audio quality by distinguishing between different audio sources like speech, music, and background noise. Users can then reduce distraction and boost the key sounds. I'll pause here for a moment so you can hear the difference creators can make with this feature.
Baby, please don't cry. We're cutting for your dinner. Baby, please don't cry. We're cutting for your dinner.
To make it straightforward for you to access this new capability and more, we are delivering them through a standard interface in a new Media3 AI effects library. That means you can adopt the feature once and it will take care of all heavy lifting to dynamically use the optimal implementations at runtime, based on device capabilities. This is helpful because these features can come from different sources to take maximum advantage of the software and hardware they run on. For example, they could be implemented in software for broad reach. They could be released as a new feature in Android platform for deeper system integrations. Or they could be a hardware accelerator model for optimized performance. The new AI effects module in Jetpack Media3 will abstract away this complexity, so you automatically get the best experience, even on devices update to provide more optimized paths. This framework is a powerful and extensible interface that enables you to stay on the cutting edge and adopt the latest advance for Google research with minimal effort. We're excited to bring these advanced capabilities to your apps and eager to see the delightfully creative experience you can craft with them. Please stay tuned for an upcoming release of Jetpack Media3 library that includes these APIs.
Finally, let's talk about the last crucial piece, Playback. Jetpack Media3's ExoPlayer is the recommended solution for media playback in Android apps, and we continue to invest heavily in making it more efficient, reliable, and feature-rich. Let's run rapid-fire through some of these improvements.
We've heard your feedback on improving the user experience during seeking. ExoPlayer now has a new scrubbing mode. Enable it via ExoPlayer.set scrubbing mode enabled. This optimizes performance for frequent user-driven seeks, like dragging a seek bar, resulting in a much more smoother experience. If you have a scrubbing UI, you should additionally configure the seek tolerance values. This allows ExoPlayer to be more efficient decoding frames while seeking. In this example, we are setting the tolerance to 8 dp before and after the seeking position, which allows ExoPlayer to find an optimal frame to seek to within that range.
Last year, we announced the Player Surface Composable, and we're continuing to add more Compose UI elements to the library, including button and state holders for playback controls like play, next, mute, and shuffle, a state holder for playback progress that can be used to create a progress indicator, and Content Frame, a composable that helps handle scaling an underlying player surface while maintaining its aspect ratio, and also has an easily enabled shutter to hide the playback content. We've also introduced the new UI Compose Material 3 module, which provides components with Material 3 design styling. This includes individual components such as playback control buttons, position and duration text, and a progress slider that allows seeking. Here, you can see the Media3 Compose demo app, which uses the new top-level player composable. This provides a basic player UI layout with customizable slots to add controls.
Preloading content is key to fast startup times, especially for short-form content. We've enhanced our preload manager with caching support and improved memory management.
We've also introduced new APIs for frame and metadata extraction, which have better reliability and format support than the equivalent platform APIs.
For remote playback, Media3 now has enhanced cast support with the new Cast Player API. This player implementation acts as a drop-in replacement to ExoPlayer for seamless transitions between local and cast playback, handling the playback state management on your behalf.
We're also happy to announce that Eclipse Video is launching on Android. Eclipse Video is a next-generation HDR video format that provides exceptional color and stunning imagery across a diverse set of devices. Android is the first operating system to adopt this new standard. Eclipse Video removes a class of issues plaguing existing HDR videos today, such as unpredictable light levels and inconsistent rendering across devices. We've updated ExoPlayer to provide out-of-the-box support for playback, so you can deliver high-quality HDR videos to your users with little to no effort.
In addition, with how much time users spend consuming media on their phones, we are putting extra focus into power saving and reliability for playback use cases. And you can explore some of these work-in-progress improvements in Media3 main branch, including PCM offload. For apps with audio-only screen-off playback use cases, enabling PCM offload can result in up to 25% battery savings based on our lab testing data. Dynamic scheduling, which allows the CPU to adapt how frequently it wakes up based on the workload. Renderer pre-warming, to efficiently prepare resources needed for playback ahead of time for lower startup latency. Stuck player detection, to give you more signals if the player ever gets stuck in buffering or playing state without making progress, helping you identify and fix issues.
So, to recap, Jetpack CameraX helps you build powerful and consistent camera experiences to capture in any scenario. Media3 Transformer makes creative and complex editing easy and performant. And Media3 ExoPlayer delivers efficient and reliable playback.
Exactly. And together, they supercharge your Android media experiences.
We can't wait to see what you build. For more information on anything we covered, check out the latest documentation and samples linked in the video description below.